Welcome to AI Frontiers, your weekly deep dive into the bleeding edge of artificial intelligence research. Today we're exploring the frontiers of reasoning with a concentrated snapshot of breakthroughs from October 25th, 2025. Our journey today involves embarking on a deep dive into AI's latest advancements, discovering the core themes shaping the field, highlighting pivotal research, understanding methodologies, and gazing into the future of intelligent systems. The landscape we're exploring today is computer science, artificial intelligence, often abbreviated as cs.AI. This is the intellectual core where AI principles are forged, encompassing learning, reasoning, and the creation of computational minds. It drives innovation from everyday assistance to grand scientific quests, forming the foundation for understanding and creating intelligent systems. A dominant theme emerging from the research is the deep focus on understanding large language model, or LLM, reasoning. Researchers are investigating chain of thought for step-by-step solutions. For instance, Shahariar and colleagues propose a finite state machine framework to visualize and analyze how models approach problems, aiming to gain transparency into internal AI logic. Another dominant theme addresses the challenge of scaling complexity and ensuring robustness in AI reasoning. Ramesh Kumar and his team revealed performance cliffs where models falter above a certain complexity threshold. Their new Deep Reasoning Dataset, or DeepRD, highlights these limitations, showing that current models can be surprisingly brittle. We're also seeing advancements in specialized reasoning domains, particularly spatial and mathematical reasoning. Wu and their collaborators introduced DynaSolid-Geo, a dynamic benchmark for vision language models, or VLMs, evaluating genuine spatial reasoning in solid geometry. This benchmark addresses flaws in existing 2D static and answer-only evaluations by focusing on multimodal, dynamic instances, and process evaluation. A fourth dominant theme is the rise of interpretable AI and domain-specific applications. Hu and their team present LIFT, a framework for truck driving risk prediction that integrates LLMs with domain-specific literature. This AI not only predicts risks, but explains the why, aligning variable importance with human expertise. The fifth pervasive theme involves novel training methodologies and reward mechanisms. Yoon and colleagues propose PACR, Progressively Ascending Confidence Reward, a dense model intrinsic reward for LLM reasoning. Nambasubramanian and his team introduced dopamine, a biologically inspired derivative-free optimizer. Key findings from this remarkable day reveal critical insights. Ramesh Kumar et al. Demonstrate that large reasoning models, or LRMs, fail catastrophically beyond specific complexity thresholds. Wu et al. Show severe degradation in VLM spatial reasoning in dynamic settings, while Liu et al. Found that hierarchical tree search significantly improves optimization accuracy. These findings indicate that current models excel in a sweet spot, but lack true generalization, underscoring the need for fundamentally new, scalable approaches. Looking at the synthesized methodologies, researchers are employing a robust toolkit. This includes the creation of novel datasets and benchmarks like DeepRD and DynaSolid-Geo, refinement of reinforcement learning techniques, such as PACR, application of structured reasoning abstractions like finite state machines, domain-specific knowledge integration via fine-tuning, as seen in LIFT, and the exploration of biologically inspired learning mechanisms like the dopamine optimizer. One selected research paper is Reasoning Models Reason Well, Until They Don't, by Ramesh Kumar et al. In 2025. This paper critically highlights the limitations of current LLMs in complex reasoning, demonstrating abrupt performance cliffs beyond a certain complexity threshold. It introduces the Deep Reasoning Dataset, or DeepRD, for scalable complexity and serves as a crucial cautionary tale for over-reliance on current LRMs. Another pivotal paper is Modeling Hierarchical Thinking in Large Reasoning Models by Shahariar et al. In 2025. This work offers a novel framework for understanding LLM reasoning processes by using finite state machines to abstract reasoning steps, increasing the interpretability of chain-of-thought reasoning. Its impact lies in providing a visual lens into LLM's internal logic and decision-making. Our third featured paper is DynaSolid Geo, a dynamic benchmark for genuine spatial mathematical reasoning of VLMs in solid geometry, by Wu et al. In 2025. This benchmark pushes VLM evaluation into complex dynamic 3D spatial reasoning, addressing the limitations of static 2D and answer-only benchmarks. It incorporates process evaluation alongside answer accuracy and is essential for developing AI capable of understanding our physical world. Looking ahead, future directions include developing models with robust generalization and scalability, intensifying focus on novel architectures and training paradigms, advancing domain-specific AI for expert-level reasoning, pursuing true understanding and verifiable reasoning processes, and increasing integration of multimodal reasoning capabilities. This AI synthesis was generated using AI tools including GPT Google, using model MODEL-MI-2.5-FLASH-LITE. Text-to-speech synthesis was performed using Deepgram. Image generation was assisted by Grok. While the synthesized content underwent review by a human expert, some oversights may still exist. All references are provided within the presentation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.